Video, I'm going to cover one of the most famous formulas in all of math, which is the area formula of a circle, pi r squared. I also will be discussing with you sectors and different things you can do with sectors, such as calculating the area of a sector, and we'll even have a few extra bits at the very end of the lesson that will be a little bit entertaining or definitely different. But let's start with something very familiar, an entire pizza pie. This pie has a radius of 9 inches, and the directions say to figure out the area of the pizza to the nearest tenth. So all it is simply is just using the formula. Area is pi r squared. And plugging in the radius, which is 9. Remember, the radius goes from the center of the pizza to the edge. So it'd be pi times 81. And it says to calculate it to the nearest tenth. I just go to my calculator and type in pi times 81. To get to pi on the calculator, remember it's pressing second and then the caret. And then type in 81, hit enter, and then round it to the nearest tenth. This is my 10th spot. I'll take a peek at my 100th spot. It's 5 or above, so I'm going to give this a shove, and 254.5 will be the area of the pizza. So 254.5, and it would be measured in square inches. So a square inch is a 1 inch by 1 inch square of pizza, which is this is not definitely drawn to scale because you might be on your phone or your iPad, but a 1 inch by 1 inch square of pizza is basically a bite of pizza. So in this pizza, there's about 254 or 255 bites of pizza. For the second question, it's almost identical to the first, except for a few small changes. Number one, I haven't given you the radius of the pizza. I gave you that the diameter is 11 inches from left to right. So before I use this formula, I definitely have to figure out the radius. If the diameter is 11 inches all the way across the pizza, then the radius would be half as much. That should be familiar to you. So that's my radius. And it's just simply using pi r squared to figure out the area. So pi times 5.5 squared, and that's where it's helpful to use the calculator. 5.5 squared times pi. Well, what's 5.5 squared, first of all? It's 30.25. So I'm going to get pi times 30.25. And if it asked me to round it to the nearest tenth, I would take 30.25 and multiply it by pi to get 95.0. But in this question, it did not say to round. It said to write your answer in terms of pi. So as it turns out, the final answer is just 30.25 times pi. And we won't do any rounding. We'll just leave the answer in its exact form. So we'll leave it up to somebody else to round it if they want to round it, but we'll make sure that the answer is as perfect as can be without any rounding. When you round something, you actually slightly get it dirty or you tarnish it. So this is a very pure answer. This is the exact area. And there's benefits to keeping it exact. Let's go to the next page and take a look at sectors. A sector is a piece of, in this case, a piece of pizza. A sector is a wedge or a slice of pizza. And we're going to be using this formula this week to figure out information about circles and sectors. So this whole proportion comes from the idea of part over whole or part over total. In these questions, you're going to be looking at angles out of the entire 360 degrees of a full circle and you're going to be looking at parts of a circle, the sectors, over the whole entire circle. So it's part over total, and it's a very similar formula to what you would have done back in middle school with working with percents for maybe the first time. The is over the of percent over 100 is sort of the same idea. With this formula today, we're going to be looking at or focusing in on three different things. How do you find the area? How do you find the central angle of a slice of pizza? How do you find the area of one slice of pizza? And if you're given the area of the sector, how do you find the area of the entire circle? So for the first example right here, they're asking me, or asking us, to find the area of one slice of this 8-inch radius pizza. So to figure out that, we'll need to apply this formula, which is very simple to remember. There's 360 degrees in an entire circle. And if we want one piece of pizza, we need to know how many degrees is there right at the center of that pizza. Well, this pizza has how many slices? 1, 2, 3, 4, 5, 6, 7, 8. So there's 8 slices of pizza. Oops. So, just back off this. Do a little erasing here and get rid of that extra bit. So, as you can hear, there's a bunch of kids bouncing on a trampoline outside. Okay, so we've got 8 pieces of pizza in an entire 360 degrees. So to figure out how big the central angle is, we're going to take 360 and divide by 8. So 360 divided by 8 comes out to be 45 degrees, which you may have guessed already based on the way that this looks, like half of a right angle. So that's going to be our angle in the formula. We're looking for how much pizza is in just this piece alone. Now, we didn't necessarily need this formula to do it. There are other ways to figure out the area, but we're going to stick with this plan because we can use this formula in many different ways. So 45 degrees is in our piece of pizza, 360 degrees in the entire pizza. We're looking for how much area is in one slice of pizza, and I'll just call it Y. You can name it anything you want, X, Y. So how much area is in the entire piece of pizza? Well, we need a formula for that, pi r squared. So the way that the calculation looks would be 45 over 360, y over pi times, well, it says it was an 8-inch radius pizza. So pi times 8 squared would be pi times 64. And all that's left to do is to cross multiply. When we cross multiply, we get 360 times y, and we get 64 times 45, which is 2,880, and that pi is still there when we cross multiply. 64 times 45 would be 2,880, but pi times 64 times 45 would be 2,880 times that pi. They're not asking me to round. They're just asking for the area of one slice. So I'm not going to type in the pi into the calculator. I'm going to leave the pi in the answer. So 2,880 divided by 360 comes out to be exactly 8. So the answer would be 8 pi for how much area is in one slice of pizza there. And remember, pi is about 3.14. So pi times 8 would be about 3 times 8, or 24 square inches of pizza. In other words, it would be about 24 bites of pizza, small bites of pizza in that one slice, which makes sense. Let's take a look at 2 more examples before we get into some other fun. Question number 2 says to find the area of 2 sectors of this 14-inch diameter pizza. So we're going to apply the same formula as before. If you want to pause the video and try this yourself, that's very good. I encourage you to do that, especially if you caught the idea of what's supposed to happen. So it's going to be the angle over 360. So it's the part over the total, and the part, the area of the sector, over the entire area of the pizza. We're looking for the area of two sectors or two slices of pizza together, because you're not just going to have one piece. Come on. So let's take a look at this other information. It says that there's 14 inches of diameter in pizza. I'm going to have to make sure I pay attention to that. The diameter is 14. All right, to use this formula, I need to figure out this angle right here. Now this pizza is cut differently than the last example. This is cut into 10 pieces. So to figure out that angle there, I'm going to have to take 360 degrees, which is the entire pizza, and split it into 10 pieces, which would be 36 degrees. So each of these angles here are 36 degrees. So together, both of those angles there in the center, it's called the central angle, together would be 36 plus 36, or 72. So in my formula, I'd drop a 72 there. Sometimes on these questions, I'll give you the central angle. You won't have to calculate it like that. So we're looking for the area of the sector. I'll call it y. And the whole entire pizza is pi r squared. And if the diameter is 14, the radius would be half as much. Remember, the diameter goes all the way across the entire pizza. So if it's 14 from coast to coast, it's going to be just 7 inches from the center to the crust, which would be the radius. So if I continue on with my formula, 72 over 36 equals pi over, or y over pi times, well, the radius is 7. 7 squared is 49. Now all that's left to do is cross multiply. I'm going to change the color so you can see it maybe a little bit more clearly. So we get 360 times y equals pi times 49 times 72. So I'll need the calculator to figure out 49 times 72, which is 3528. And all that's left to do is divide both sides by 360. He did not say to round, so I'm not going to type pi into my calculator. I'm going to leave pi in the answer. So at the very end here, it's just 3528 divided by 360, which comes out to be 9.8. So y would be 9.8 times pi, which if you did multiply it by pi, you end up getting about 31 square inches of pizza. So in that particular pizza, about 31 little bites to eat 2 pieces, which does sound right. There's one more question here before we get on to some other things. Is figuring out the measure of the central angle given the area of the sector and the area of the entire pizza. So to answer this question, we could follow the same plan. It's a nice idea to draw a picture of what's happening. I could do better. Let's see. Draw a better freehand circle. Well, not much better, but maybe it's pizza and it's made out of dough. So it says that the entire circle is worth 36 pi for the area. And we have about 10 pi in our sector. So I'll change the color. So 12 pi would be half of the circle. Or I'm sorry, half of the circle would be about 18 pi. And this says it's 10 pi, so it's definitely less. So that's a picture of kind of what's happening here. They're giving us the area. They're giving us the area of the sector and the circle. And if we follow the formula, where it's the angle over 360 equals the area of the sector, part of the circle, over the whole circle, we've actually laid out a good plan to figure out how much that angle is worth. So I'm using the formula in a slightly different way. Cross multiplying, and you get 36 times pi times a equals 360 times 10 pi, which would be 3,600 times pi. There's only one more step left to do, and I can do this without a calculator, and maybe you can too, is to divide by 36 pi. It's telling me that my area is going to be worth, well, the pi's are going to cancel, and 3,600 divided by 36 would be 100. So the area would be worth 100 degrees. Or the angle would be worth 100 degrees. There in the center. All right, so that's just the basics, and we're going to be covering this, like I said, all week, and this is just an introduction to get you started. Before we actually get into showing you what the assignment looks like, I thought I'd give you a little, I don't want to say it maybe call it a treat, something I'm just calling the overtime show. So Buffalo Sabre great announcer Rick Jeanneret used to say when the Sabres got, and still does say actually, he's still the announcer for the Sabres. He'll say, we're going into overtime. This one's going into overtime. So here's a little overtime show for you. Here's a question that students sometimes do ask, and I think it's a fantastic question. Why is the area of a circle pi r squared? Where does it actually come from? And maybe you've never even seen that before. I'm pretty sure you've seen pi r squared. Possibly your teacher showed you where it comes from. Well, it comes from this. It comes from this idea right here. It's pi r times an r. Well, how do you get that? And to show you that, I've got I'm going to lean on something from the internet to help me show this to you. All right, so if we have a circle and we unwind it, but unwinding it means if we just laid it out. So let's say we took a wire and we wrapped it around that circle and we laid it flat. The perimeter of that circle is called the circumference. So if we unwind a circle, that circumference is called the length of the circle or the perimeter of the circle. So from here to here, the formula is pi times d, also known as 2 pi r. If we take that circle and break it into sectors and unwind it, we could actually stretch out that circle to just about reach the full length of that circumference like that. I'm not done moving those slices yet. I'm going to take those slices and close it up like a mouth to make a parallelogram. And the area of a parallelogram is base times height. The base here times the height here. Okay, so I'm not done yet. A parallelogram. I can maybe do better than a parallelogram. So let me unwind it. Put it right back to where it began. And let me start by taking that circle and breaking it up into smaller parts. Let's try 72 parts. You can unwind the circle. It makes all these little teeth. It almost looks like a comb now. And now we can take those and rearrange them that way right there. And that blue and red area together is the area of a circle that just split up. Now it turned into a parallelogram, but this parallelogram is almost a rectangle. That's just a little bit crooked there. So I can even do better than that. So let me rewind my circle back. And instead of breaking it up into 72 sectors, let me break it up into, let's see how far it lets me break it up into 200 parts. So I'll have 200 little teeth They're opening up. Isn't that beautiful? The red and the blue makes up the full circle. And if I take a circle apart and reconnect it, I can make that circle into a rectangle. And to figure out the area of a rectangle, it's just length times width. Now, if the length of this line right here, which represents the entire circle, is pi times d, or 2 pi r, then this is the midpoint of that segment, which makes this length right here 1 pi r and makes this length here 1 pi r. So I'll get, to figure out the area of that rectangle, would be the length, which is pi times r, times the width, which is r. So pi times r, which is pi r squared. So that's a little bit of a enrichment for you, so you could actually see where that formula comes from. So you're going to be finding the area of the shaded region to the nearest tenth for the first 3 questions. For the next 3, you're going to be leaving your answer for the area in terms of pi. And I think, there's one more page. On this question 7, you're going to be finding the central angle. We did an example of that. And 8 is very similar. Well, 8 is finding the area of a circle. We'll let you figure that out. And then question 9 and 10 are asking you to tell the difference between a few different terms in geometry.